Okay. So, we continue from where we stopped. Now, consider an example. Suppose n equal to 8. So, I have got x 0, x 1 dot 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 up to x 7. So, suppose I have got the h 0, h 1, h 2, h 3. Suppose they are available, okay, because n is 8. So, n by 2 is 4. So, if you take the even points x 0, x 2, okay, x 4, x 6, put them and then take their DFT and they are coming out h k. And here suppose you have got this for the odd part. Okay. Then from this formula you have to find out the output, final output x at 0. So, that will be h 0 plus this factor times g 0. This factor, by the way, e to the power excuse me, we adopted notation, very widely used notation. This factor is called a Twiddle factor. Okay, we call it W n. Okay, and so this is W n to the power k. So, it was W n to the power k here, this term. Okay, so start with k equal to 0. I have to find out capital X 0, x 1, x upper half. So, suppose I have to find out x 0. That will be h 0 plus W n whole to the power k, k is 0. So, W n to the power 0 into g 0. Okay. So, suppose I multiply it by such to W n to the power 0 is 1, but I am still writing, and then I add this. When two arrows meet a point, assume there is an adder here, okay, because if we start drawing adder everywhere, it will be very clumsy and complicated. So, when I write some constant by the side of an edge, that means we are multiplying this signal g 0 by this and then moving it up, and it is getting added. So, what you have is h 0 plus W n to the power 0 into g 0, that is your x 0. On the other hand, if k jumps from 0 to 0 by n by 2, n by 2 is here is 4. So, from 0 to 4, k earlier was 0, I have found out. Now, 0 plus n by 2, that is 0 plus 4. I will have the same h 0, because h k is periodic over n by 2, so n by 2 is 4. So, h 0 and h 4 they are same, g 0, g 4 they are same, but only this part will be minus of what it was. So, therefore, what it will be same h 0 and same g 0, but g 0 now will be multiplied by the same constant, but after that a minus sign, so it will be subtracted. So, g 0 multiplied by the same constant, g 0 into this, g 0 into this, but after that it will be multiplied by minus 1 or and then added with the same h 0. You can either multiply by minus 1, but in practice we will not use a multiplier, we will just use a subtractor. Adder, we know how to do addition. Okay, in binary domain, we can also design a subtractor. If you are using 2's complement number system, you take 2's complement and add, you get the same thing, but this will give me x 4. Similarly, by the same way, suppose here you want to find out capital X 1. So, it will be h 1 plus g 1 into W n to the power 1. So, that means g 1 into W n to the power 1, this will be added, we get x 1, and now instead of capital X 1, if k jumps from 1 to 1 plus n by 2 is 4. So, 1 to 5, you will have the same h, same g, that is h 1, h 5 same, g 1, g 5 same. This factor will be same, but it will just undergo a sign change, it will become minus. So, once again this will be your x 5. Same manner k equal to 2, k equal to 2 means h 2 plus w n to the power 2 g 2 . And instead of 2, if k jumps from 2 to 2 plus n by 2, that is 4, that is 2 plus 4 is 6. You will get the same thing, same g n, but they will undergo a minus sign, it will come from here. And by the same token, lastly also okay, G 3 will be multiplied by w n to the power 3, then added, and in this direction minus in the same logic, and then added, that will give you x 7. Okay. But what is capital H 0, H 1, H 2, H 3 is a DFT of x sequence x 0, x 2, x 3, x. So, this is that it was computing that n by 2 point DFT, n by 2 point DFT. On what sequence? This was working on this sequence x 0, then next even, then next even, then next even, and this was working on first odd, next odd, next odd, next odd. This is 5. Okay, on this. But this is a sequence. On this also I can apply the same philosophy. I can take out its even component, these two, the 0th term, second term, and odd components, these two. So, I will have a subsequence x 0 x 4 and another subsequence x 2 x 6. Okay, so, by the same token, this DFT can be obtained now. This box has no meaning. This will be another box now. This was 4 point, this will be 2 point. This will give you, so I already have used of H and G, I will not use any name here. It will take this x 0 x 4 here as a 2 point sequence, and it will give 2 outputs. And this will take x 3, sorry, this will take x 0 x 4 and this will take x 2 x 6. 0th point, first point, second point, third point. First and third are the odd ones, so x 2 x 6, and 0th and second, that is x 0 x 4 upstairs. X 0 x 4 I calculated 2 point DFTs, they come out here and here, here also they come out. Then what I have to do? This will get multiplied by now w, earlier it was w 8, n was 8, you can instead of w n here you can write as w 8 in all of them. I wrote in a general way, all of them it is w 8 everywhere, okay, because the total length was 8. Similarly, here the total length is 4. That is the length of the sequence is 4. I am trying to find out its DFT. So, n is 4. I am dividing this into 2 sub hubs, 2 hubs, but w formula, the w n was coming from this length, final length, that is 4. That is why now this will be w 4 to the power 0, w 4 to the power 1. After that, they will be added. And then this direction it will undergo -1, this direction will undergo -1, this that we have already seen. So, and then this will be here, this will be here, it is just replica, I mean same thing, and this will go like this. Okay. Same way x 1 and x 5 they will come under this box x 1 x 5 and x 3 x 7 here, n is 4 again. So, w 4 here W 4 to the power 0, W 4 to the power 1, then this will get added. Here there is an adder, mind you, I am telling you, these to get added. And in this direction, this is minus 1, it get added, this get added. So, it is here, it is here, it is here, all right. So, now again this is having two point sequence now, x 0 okay, and x 4. This was having x 2, x 6, I am writing horizontally x 2, x 6. This was having x 1, x 5, and this is having x 3, x 7, right. So, 2 point. Again I break it into its even part, odd part, very simple now. Even part has x 0, odd part has x 4. So, even part is a 1 point sequence, odd part is a 1 point sequence. So, 1 point sequence of only 1 point DFT, and that DFT is same as the itself, summation x n e to the power minus j 2 pi k n by, okay, in this formula, the general DFT formula, if capital N is 1, it is n 0 to 0. So, x 0 into to the power 0, so x 0. So, capital X k, there is k equal to also 0, only one possibility. So, that is same as the capital X 0 is same as small x 0. So, DFT is the value of the sequence itself. So, x, that sample itself is DFT. Okay. 1 point sequence, 1 point DFT, sample value and its DFT are same. So, I will have 1 point here and 1 point here. Okay. So, W here it was 4, now W 2, and this will be what, x 0, x 4. Okay. And this will get added, and this will get minus 1, then added. So, boxes do not do anything now, you can remove the boxes, it was just for explaining. Similarly, here x 2, x 6, 1 point sequence, 1 point sequence. So, its DFT itself, x 6 its DFT itself, h k, g k, like that. So, this we combine, this I multiply by again W 2 to the power 0, because W n you go from 0 1 up to n by 2 minus 1. So, n here is 2. So, 2 by 2 minus 1 is 0. So, you can go from 0 to 0 only. Okay. And then you add, and here minus 1 like this. Okay. Then again by the same philosophy, sequence is x 1, x 3. Now, W to the power 0 is 1, I agree, but still I will be writing like that. Last one is x 3, x 7. Okay. So, this is the entire diagram you see. Now, let us see what computational advantage we get. We suppose have here n is 8, but suppose a general n. For general n, I have got this box, this is suppose generating, this is by hook or crook I have got h k for k equal to 0 1 up to n by 2 minus 1 and g k also. So, for this butterfly, these are butterflies. Okay. How many are there? For this structure, this multiplication is common. For the next butterfly also this multiplication is common. Next butterfly this is common, this is common. How many butterflies? N by 2 butterflies. Okay. Like this one and this one, they together form 1. Then this one and this one, they form 1. So, total n by 2 butterflies, and for per butterfly only one multiplication, So, you have got n by 2 complex multiplications. Of course, you can say that W n to the power 0 is 1. So, no need to multiply, so it will be n by 2 minus 1, all those things I am not doing. A very rough calculation, n by 2 multiplications. right. Then again I assume that these are somehow generated. Now, how to generate them? This is again generated by this, that suppose these two DFTs are available. Okay. Then you have got how many? This was n by 2, n by 2. So, now n by 4, n by 4, n by 4, n by 4. Here n by 4, n by 4, how many butterflies? N by 4 butterflies. Here it was n by 2, n by 2, how many butterflies? N by 2. Okay. N by 2 because one from here and here and another from here or here. Okay. One butterfly means you take one output and one output frame combine this way after multiplying, and then again go in this direction by multiply by minus 1 and in this direction. That is one butterfly. So, obviously, if you use n by 2 here, n by 2 here, you have got total n by 2 butterflies. Similarly, if it is n by 4, n by 4, you will have n by 4 butterflies. Like n was 8 in the previous example, so 8 by 4 is 2. So, you have got one butterfly this, another butterfly this. So, n by 4 butterflies. Okay. And again, per butterfly how many multiplier? 2 multipliers. Okay. So, n by 4, how many butterflies I have got? N by 4. Per butterfly 1 multiplier. So, n by 4 into 1. But I have got n by 4 here, another n by 4 here. So, again n by 4 into 2. So, n by 2. Next time n by 4, each n by 4 will give rise to n by 2, sorry, n by 8, n by 8. So, total n by 8 butterflies, per butterfly 1 multiplier. So, n by 8 multiplier. Okay. But how many n by 8s? Because this is giving rise to n by 8, n by 8. This is giving rise to n by 8, n by 8. This is giving rise to n by 8, n by 8. This is giving rise to n by 8, n by 8. So, how many? 4. Okay. So, it will be again n by 2. I repeat, here what I had? These two blocks, like these two blocks gave rise to, I mean, because I was computing this DFT. So, these two blocks they gave rise to 2 butterflies. In general, it was n by 2. So, n by 4, n by 4. So, these 2 blocks give rise to n by 4 butterflies, n by 4 into 1 multiplication, because per butterfly 1, and one more case here. So, 2 into n by 4. Okay. Now, this was n by 2, n by 4. Now, this is n by 4. This is giving rise to n by 8 by n by 8. So, n by 8 butterflies, per butterfly 1 multiplier. So, n by 8 into 1. Again, here also n by 8 into 1. Here also n by 8 into 1, n by 8 into 1. So, 4. So, 4 into n by 8, again n by 2. So, every stage, this is one stage, this is one stage, this is one stage. Every stage, your length of the DFT reduces, but number of such parallel butterflies, parallel this increases. So, total multiplier remains same. So, if you have got say k number of stages, L number of stages, L into n by 2, that will be total multiplications. Now, how many stages you have? N by 2, okay, n division by n by 2. Then next time n by 4, next time n by 8, finally, it will be 1 point. So, that will happen only if it is n by n. Okay. So, how many stages I have? It is n by 2, then n by 4, n by what? So, n by actually you remember n was 2 to the power r. Okay. So, we will basically have r stages. Okay. So, r into n by 2, you will have r stages, like n was 8 here. So, 2 to the power 3. So, one stage, one stage, one stage. Per stage I have got n by 2 computation. N is 8, you can put 8 here or write n by 2. So, 3 into n by 2. Why r? Because n by 2, then n by 4, then n by 8, n by 2, then the basic block was I am dividing into n by 4, then n by 8. So, one stage, another stage, another stage. So, how many cases? It was 2 to the power 1, 2 to the power 2, 2 to the power 3, up to 2 to the power r, then only n by n 1. So, I will get 1 point. Here I am taking n point sequence breaking into n by 4, n by 4. okay, n by breaking into n by 2, n by 2. Total was length n, even point here, odd point here. Okay, that is corresponding to these DFTs. So, n by 2, n by 2. Then again each n by 2 was broken down into further half. So, n by 4, n by 4, n by 4, n by 4. They are corresponding to this sequence x 0, x 4, x 2, x 6, x 1, x 3, x 3, x 7. Then again this was broken into 2, n by 8, 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 till the point I get 1 point sequence. So, x 0, x 4, it became x 0, 1 point, there is even point of this 2 length 2 sequence. It was length 2, x 0, x 4, is the even point, odd point. So, I got x 0 the only point, even point, x 4 the only point, odd point. So, it is a 1 point sequence. Then only I can stop. So, when do I reach 1 point? I started with n by 2, stage 1, then n by 4 to the power 2, stage 2, n by 8, stage 3, 3 stages, n by 2 to the power r to the power is n, then only n by n is equal to 1. So, after r stages, sequences, then breaking into subsequence, then breaking into subsequence, I get 1 point sequences. That is, here it was 4 point, 4 point, then 4 points were divided into 2 point, 2 point, 2 point, 2 point, then 2 point was divided into 1 point, 1 point, 1 point, 1 point. So, sequence length becomes 1 point. That happens only when I have got r stages. Okay. I repeat again, start with n by 2, n by 2 point, n by 2 point. Then you go for another stage, everybody is n by 4 point, not still 1 point, then n by 8 point. So, when will I have 1 point sequence, like x 0 is a 1 point sequence, x 4 is a 1 point sequence. When in the denominator I have n, n is 2 to the power r. So, I started with 2 to the power 1, 1 stage. If I go up to n by 4, 2 stages, 2 to the power 2. If I go for n by 8, 3 stages, 2 to the power 3. So, if I go up to 2 to the power, 2 to the power r, r stages, then only I get 1 point sequence, I stop this business. So, r stages, per stage total computation is n by 2 complex multiplications. So, total will be r into n by 2, which also you can write as r was, what was r? This. So, log 2 n base 2 n is your r, right. So, that is why this famous formula comes, n by 2 log 2 n. So, it is a huge saving. Originally, it was n square. Suppose n is 64, 64 square, and it is 32 into, if n is 64 is 8, log 2 64 is 8. So, 8 into 32. So, you have 32 square on one hand and it is just 32 into 8. See the kind of not even 32, 16 into 8. Sorry, 32. If you have n equal to 64, sorry, if n equal to 64, originally you had a 64 square, and here 64 by 2, that is 32, and log 2 64, that is 8. So, see the huge difference is 64 square. So, 32 into 2 into 64, that is 32 into 128, and here it is only 32 into 8. So, a huge difference, okay, 16 times less, and if the capital N is large, your gain will be more and more. Lastly, you see our original sequence was in this order, x 0, x 1, like if you write a vector, it will be, if you write in a vector form, it will be this kind of form, x 0, x 1, x 2 dot 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 x 7, write a vector form. This is a sequence, but look at this order. This is, I am writing here only, this is different. This is x 0, then x 4, then x 2, then x 6, then x 1, then x 3. It cannot be 3, it is 5, x 5, then x 3, x 7. So, the whole order has got disrupted. So, question is, what is this new order? If I give you a vector and vector is long, there is no point in going back calculating like this and forming the new vector. There is a way to get this new vector. Okay. How to get this new vector? Now, suppose your n is 2 to the power r. So, I have got numbers 0, 1, x 0. So, index n x n will be 0, 1 dot 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 up to n minus 1. Suppose as an example n is 64, that is 2 to the power 8. Okay. So, it will be 0, 1 up to 63, okay, or say n equal to 16. So, it will be 0, 1 up to 15. Now, all these decimal numbers, integers 0, 1, 2, 3 up to 15, if I want to represent them by binary words, how many bits will require? 4 bits here, 2 to the power 4, 16. So, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, like that. In general, if it is 2 to the power r, I will require r bits. So, every index value n 0, 1, 2, all the index values up to capital N minus 1, like 15 here, or if capital N is 64, it is 63 here, that will require odd number of bits. If n is 64, 2 to the power 6. So, we will go up to 0, 1 up to 63. So, 0, 1 up to 63, all these indices can require, if you want to represent all of them, you require 6 bits. If n is 16, that is 0, 1 up to 15, that is the index set, the small n goes over this. Then, if you want to represent each value of small n time index, I will require 4 bits, 2 to the power 4 is 16. So, in general, I have got suppose A0 LSB, A1, A2 dot 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 A, how many? R minus 1. So, how many bits? 0th bit, first bit, second bit up to r minus 1th bits, total r. Okay. This is how my n is. And what is the binary value? A0, what is the decimal value? A0 plus A1 into 2, A2 into 2 to the power, and these are all positive. I am not considering a negative number here, negative is impossible, this is the range. So, A2 to the power 2 to the power 2 dot 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 2 to the power r minus 1. Okay. Now, suppose n is even, in that case, if n is even, then if it is divisible by 2, that means A0 cannot be 1, A0 has to be 0, because A0 1, this remaining part, you see they are all 2, 2 to the power 2, 2 to the power 3 up to 2 to the power minus 1. So, that is divisible by 2, but if it is 1 and if you divide the entire thing by 2, there will be remainder 1. So, it is not be divisible by 2. So, n even means A0 must be 0 and n odd means A0 must be 1. Now, I am dividing the sequence into even component and odd component. So, what I will do? I will basically 0, 2, 4, 8, they will come under one umbrella, and 1, 3, 5 that will come under one subsequence. That is, you remember HR and GN, HN, GN, 2 length n by 2 sequences. But here indices will be 0, 2, okay, in terms of x, x0, x2, that is HN is x2n, GN is x2n plus 1. So, it is in terms of x, x0, x2, x4, x6 like that. Okay. So, n will be taking even numbers. That means, I will take the n, it is their binary representation of this form for various n's. Whenever A0 is 0, it is even. So, I will put them in one half, and whenever A0 is 1, it is odd, I will put them in another half. When A0 is 0, I will consider 0, 0, 0, 0, 0, then 0, 0, 0, 0, 1, 0, that is decimal value 2, 0, 0, 0, 1, 0, 0, okay, that is decimal value 4, then 0, 0, 0, 0, 1, 1, 0, decimal value 6, like them. So, in that order I will put them. Okay, same for the odd part. Okay. I think time is up for this class. I will continue from here in the next. Thank you very much.